Welcome to the next video of the second module. In this video, I am going to discuss the Legendre and Cauchy differential equations. And this is one of the question for variation of parameters. Anyway, let us skip this one. Working procedure for solving the problems. Step 1. We ensure that the equation is in the form of Legendre or Cauchy's linear equation. Sometimes we have to employ some simple techniques to bring it to the standard form. We take the substitution as t is equal to log of ax plus b, or e power t is ax plus b in the case of Legendre equation. We assume the results ax plus b into y dash is equal to a of d into y. Ax plus b whole square into y double dash is a square d minus 1, etc. And in the case of Cauchy's, we take the substitution t is equal to log x or x is equal to e power t. And we assume the results as xy dash is equal to dy and x square y double dash is d minus 1y, x cube y triple dash is d minus 1 d minus 2y, etc. Where d is d by t, in order to obtain the linear differential equation with the constant coefficients. We solve the linear differential equation with the constant coefficients to obtain y is equal to yc plus yp in terms of t. We substitute for t and present the solution in terms of y and x. Problems on Cauchy's linear differential equation. Solve x square d square y by dx square minus 3x dy by dx plus 4y is equal to 1 plus x the whole square. Put t is equal to log x or e power t is x. Then we have xy dash is equal to dy, x square y double dash is d minus 1 of y, where d is d by dt. Hence, the equation reduces to d square minus 4d plus 4 of y is equal to 1 plus 2 e to the power of t plus e to the power of 2t. Then the auxiliary equation will be m square minus 4m plus 4 is equal to 0. That gives us the roots as m is equal to 2, 2. Then the yc is given by c1 plus c2t of e power 2t, and yp is given by 1 upon d square minus 4d plus 4 and 2 e to the power of t divided by d square minus 4d plus 4 and e to the power of 2t divided by d square minus 4d plus 4. Let us name them as p1, p2 and p3. So p1 is given by 1 by 4, p2 is given by 2 e to the power of t, and p3 is given by, the denominator will be 0, therefore we will replace that differentiation of this denominator and multiply t. Once again it will become 0, then again we will multiply t to the numerator and differentiate the denominator. Thereby it reduces to t square into e to the power of 2t by t. The complete solution hence will be equal to yc plus yp. Next question. Solve x square y double dash plus xy dash plus 9 is equal to 3x square plus sin log x. Put x is equal, log x is equal to t and e power t is x. We have xy dash is equal to dy, x square y double dash is d minus 1y. Hence the equation reduces to d square plus 9 of y is equal to 3 e to the power of 2t plus sin t. And m is equal to plus or minus 3i. Therefore, yc is c1 cos 3t plus c2 sin 3t. And yp is given by 3 e power 2t by d square plus 9 and sin 3t by d square plus 9. Let us call them as p1 and p2. Where p1 is 3 e power 2t by 13 and p2 is denominator will be 0, and we multiply t and differentiate the denominator and simplify, we get minus t cos 3t by 6. Hence the solution is y. Thank you.